So now I'm going to talk about set of sets. This is a slightly confusing topic. I think it just gets easy with practice, but you should expect to be a little confused about this in the beginning. Which I mean, it's okay to be a little confused about this in the beginning. Just like trust that when you do enough problems, it'll get easier. All right, so what is the deal with set of sets? Recall that we defined a set to be a collection of objects. But we never specified what an object can be. And what that means is there are some rules to what the object can be, but the rules are very lax. And in particular, the objects can themselves be sets. So what do I mean? Here's an example. I can look at this set 1, 2, 3, the set 1, 2, and I can form their collection and call this the set T. Okay, now here's the subtle point. The elements of T are 1, 2, 3. So the elements of the set T are themselves set. 1 is not an element of T. And also 1, 2, 3 is an element of T. It is not a subset. Set T has 2 elements, so the size of T is 2. How many subsets should T have? Total number of subsets of T must be 2 to the 2, which is 4. So T must have 4 subsets. Let's see which ones. Let me just rewrite what T is. The 4 subsets of T are as follows. The first is T itself. This is the subset of size 2. Then we have subsets of size 1. And these are the one that contain one element of T each. And these will be, and finally, the subsets of size 0, and that is the empty set. So these are the subsets of T. It can get really complicated. So let me give you one more example. If I were to take the set, I can form such a set. Here the elements are the number 1 and the set containing number 1. So if I were to write the elements of S will be 1 and the set containing 1. So 2 elements. If I were to write the subsets, here's where it gets weird. You have the whole thing, then you have 1 itself and the set containing 1, and then you have the empty set. So the weird thing happening here is 1 is both an element and a subset, and that is because this one comes from this one and the yellow one is that there. You can even have an empty set as a set. So another example, let me say U can be this. U is not an empty set. It is a set that contains the empty set. So the size of U is 1. The subsets of U, there should be 2 to 1, which is 2 subsets of U, and the 2 subsets of U are the empty set and the set containing the empty set. Finally, I want to tell you about the power set. Given a set S, the power set of S is the set whose elements are subsets of S. And this is usually denoted as P of S. And let's do an example. So if we do the above examples where U was the set containing the empty set, then P of U will be the empty set and the set containing the empty set. If let's do some simple example. Let's say V was the set 1, 2, 3. Then P of V will be the set containing 1, 2, 3, 1, 2, 2, 3, 1, 3, 1, 2, 3, and the empty set. The size of the power set is 2 to the size of the original set. This is just a fact. We do not yet have the tools to prove this. We'll do this in combinatorics.